New means the main character is new, but what does it mean? In the movie, sometimes he is called as D1. Right?
The most powerful person.
Yeah, D1, so you can rearrange the and Neo. Also Neo, it means the new, something like that. Anyway, so what is the big data? I started my research and the teaching. Actually, I started to prepare the teaching from the 2012 at that time. Unfortunately, I copy and paste the definition of wiki, definition of big data from wiki. So that was this one. Data set with the size beyond the ability of common use the software tool to capture, create, manage, and process the data within a tolerable elapsed time. And nowadays, I did last week to copy and paste the definition of the big data from wiki. It's a broad term for data sets or larger or complex traditional data, blah, blah, blah. Why don't you read it? And what's the difference? The definition from 2012 and nowadays. Bigger? So, any difference? Yeah, it's bigger. And I will give the couple more minutes. So you may realize, in addition to the bigger size of the data, but also it's a large or complex. Also, it's a predictive analytics. Not only just big data, huge amount of data. From the data, big data itself includes something analytics, data analytics. So that is called the predictive analytics. Not just analytics, we analyze the data for a long time. In the math or the statistics, we did. Even nowadays, without using the big data, we are doing data analytics. But that's different from the big data analytics. Big data is, we will see the difference detail, but it's mainly predictive. We try to predict. Like in the matrix, to predict whether Neo select the left-hand side or right-hand side door. Okay? The traditional data analytics is due to the limitation of the processing. For example, in this room, what is the characteristic? How I can describe this data, this room information, the student, 27 students. At that time, long time ago, I can use the statistics, like the average age of this room. 35? Younger? 30? Younger? 16? So anyway, so or maximum or minimum, standard deviation, and average. So that is a traditional way. So we make the model of the student. So that is the traditional data analytics. What about the big data analytics? We don't care. So such an existing model or whatever. Just put together, then try to find something important information in this room. Whether correlated the feature or characteristic of our huge amount of the student. For example, the age and grade. Is there any relationship? Or something background and the final grade. So if we can find something correlated data, then it is our knowledge. Okay, that is a predictive analytics. Also, we are going to use advanced method to extract such a value. That is a similar thing. Okay, to find the value of the information. So definition of the big data changed from just the size of the data to the data analytics. Okay, that's the important thing in the big data. And also Gartner defined the big data as the high volume, high velocity, and high variety. This is a well-known definition of the big data. We will see each and every for each what does it mean. And also IBM add one more thing, so we will see. Even the big data is listed on the Oxford Dictionary and other very popular dictionaries. Okay, they said it's not just computing power, the large data set, and also it's something important to me. Then what about my definition? My definition of big data is like this image. What can you see in this image? A lot of the data. So actually in the Matrix movie, green means distal data. Distal. 0 or 1 distal data. You can see something, sometimes the scene shows a greenish. Okay, like this one. That means it's a digital matrix forward. Other little bit darker color means it's a real human life society. It's a collapse already. Okay, because if you watch the Matrix and the entire Earth, actually the man and machine fight each other. The man decide, okay, cover the entire Earth by the cloud because machine cannot survive without power, solar energy. But unfortunately, the machine find the way to get the energy from the human being. That is a matrix actually. But anyway, so this is a digitized data, or data. However, can you see something behind the letter? Can you see something silhouette? What is that? What are they? This is the Neo, and this is the Trinity. This is the Morpheus. Morpheus. Like this one. So if you can find something behind the data, valuable thing, that is a big data and data analytics. Okay? We can have the bunch of different types of the data, like this one. Okay? Sometimes it's moving and down, but anyway, our goal is to find the value of such a data, like their not silhouette, their images from these matrix images. So we will see each component of the Gartner, the definition of the big data. First, the volume. Needless to say, the big data is big. Okay. Large. You can see the exponential growth of the storage, and also it's from the terabyte era into zettabyte era. So also the Twitter, for example, is the Twitter. Twitter grows exponentially. Exponential growth is not the special. It's a typical in our life, like the exponential growth population. Population grows exponentially. Also decrease. Decrease is exponentially decrease. Linear is a very specific case. So that is the reason probably in your math, calculus math, you learned about exponential growth and gain and decay of the math. Like if you have the exponential growth function or decay function, y is equal to f of x, then derivative of y is equal to k of y. Do you remember? Yes. You need to study calculus. So that is exponential. So exponential increase of the data. So it will be easily the several zettabyte data, 40 zettabyte data in 2020. Okay. What about the variety? Variety means in big data, in traditional data, it has only alphanumeric data and it's a structured data, right? But in big data, we don't care the types of the data. It can be the alphanumeric data, text data, and numerical data, but also image, video, and streaming data, and multidimensional data, time series data, all types of data will be considered. Okay? Because of that, it's not easy. Why? Because in traditional data type, because alphanumeric data easily organized by using the relational database model, that we can put such a data into the relational database model. It's a very well designed the template, then fit into the template such a data. So it's easy to access, search the data using SQL language. What about the big data? Big data, because due to the nature of the big data, we cannot use a traditional data model like the relational model and the other. So instead, we need to find a different way. Okay, so that is the second characteristic of the big data. Okay, and speed, velocity. Because of the big data, it's the size of the data. When we process such a data, it will be decreased, right? It will take a longer time. Then we cannot process, we cannot handle, we cannot manage such a big data. So it should be very fast. So we need the speed to process the data, especially for data analytics. So why do we need the data analytics? Why we need to predict? So we need to quickly decide something problem, decision, quick decision. To do that, so such a processing should be very fast. For example, there are two examples here. So e-promotion, when user log in the Amazon need to pop up right away. Suggest one. So sometimes, surprisingly, when I log on the Amazon to search this textbook, then surprisingly it shows the new edition of the discount, because I purchased the third one, the before what I searched it, right? So if it takes some time to show this one, you may lose the chance to hook up the customer, right? It's the same thing in the healthcare monitoring or the healthcare system. So as I gave you the example of the surgery, it should be very fast. So speed is another important thing, characteristic of the big data. So in addition to the volume, variety, and velocity, IBM suggests one more thing, that is the velocity, to keep the line of the velocity. In other words, it's called uncertainty data. What is uncertainty data?
It's not same.
It's not same, which means the traditional data are the same. Yeah? So like the university database, they have all the same data? No. But that means uncertainty data, or in other words, in doubt data.
Not maintaining integrity.
Hard to
Integrity.
Close. So why don't you think about the traditional data set I have in this room? What is the average age of this room? It's already determined. Even though we do not know right now, it's already determined, like 2.25 years old average. So determined already. But because of the limited power, it's not easy to calculate all the things. That sometimes we can sample 1, 2, 3, then the average. That's what we are doing, like the presidential campaign. We cannot ask all the person, who are you going to vote for, right? Instead, we can sample and estimate. However, it's a determined. So that's the deterministic. That's the fixed. However, in the big data, we don't know what is the truth. Okay? Just like the Neo can decide the left room or the right room. So depending on the situation, or depending on the something condition, it can be either this one. So we can just add it. Okay? Sometimes we cannot find any valuable information in the big data. That doesn't mean that's a failure. Okay? It may not have, we are not capable to get such a data. So sometimes we can get from the huge amount of data, we can find something related information. Okay? So it's not fixed. We are not going to find the predetermined the truth from the big data. That's the traditional way. Instead, we try to find unknown, something the characteristic of the data, using data analytics. That is called the data in DAO. So nowadays, it's true, we are living uncertainty data era. It was the deterministic data era, okay, like the Isaac Newton style, the old traditional science and the society. But nowadays, everything is a probability. Okay, we may have a chance. We may have the probability to decide that this one, 60%, 40%, something like that. There's no clear boundary to determine. So that is the last characteristic of the big data, veracity or the data in DAO. That's very important, the characteristic of the big data. Okay, especially when we are using the data analytics technique. So we already seen the source of the big data. Nowadays, social media data is one of the biggest sources. Most of the people nowadays, even though I have the three the PhD students who are doing the research on the such a big data, they are doing the social media analysis. They try to find something, the model or the something analytics on the Twitter data or the Flickr data set or the Facebook nowadays is very difficult because of the privacy issue. So in your project you can also select such a social media data. That's also one of the good example of the data set that you can use. And scientific instrument we have, for example, even though I forgot the name of the spaceship. It's a spaceship or that traveled to the Pluto recently. What's the name of that? Anyway, the space. I don't think that's a spaceship, but anyway, they sent the images and the data, scientific data. I know that's not huge data. It's very slow, the bandwidth, narrow bandwidth, but because of that, it generate a lot of the data. Also, polar research and something, the ocean research from such a scientific instrument, we receive a huge amount of the information, data, and mobile device. As I mentioned before, the mobile device, the smartphone, keep generating huge amount of data. Also, very, very important in terms of marketing. Okay, if the company knows my personal information from the cell phone, definitely they will be happy for their marketing. And sensor, we will have the huge. Sometimes we may not realize the existing of such a sensor, our life, but even camera is on other types of the sensor, so we can get the data from such a sensor. Okay? Then, when we have such a big data, how can we use such a big data? Okay, we have as I mentioned, we did something data analytics in the business. That's called the business intelligence. I don't think we have the student from the technical management. Is there any? I think the technical management student probably learn about business school, learn about the business intelligence. That is the reason. I believe there are three different approaches or three components in the big data system, big data analytics. One is our computer science, because anyway data is from the computer. So big data analytics from computer science. We are interested in how to manage, how to store, how to process, how to speed up to process such a data, or how the algorithm to process, like the clustering algorithm, data mining algorithm, classification algorithm. What else? Nowadays deep learning, which I'm not very familiar with yet, but once I got the idea, I'd like to share with you. Anyway, so that is a computer science. Another approach is from business. Anyway, money is our goal of to analyze such a data. It's not for fun. Is it for fun? No, it's not. It's for money. Okay, we need the money. So that is the goal of the business school, the business access. So they need a lot, like the business intelligence software. So they use a statistical tool, like the SAS, or nowadays the R programming is used for such a data analytics. So because of that, recently the business school also offer big data course. I think the technical management offer, so they teach very basic SQL and very basic. The programming also very basic data analytics. This semester as far as I know. My PhD student is teaching that course for the business school. The third one, so computer science and business, what else? Marketing is part of the business, right? What else?
Storing of data.
Storing? Storage, you mean?
Yeah.
It's a computer science aspect. So we need to think about how to store such a data, how make the storage such a big data. What else? I think that is the most important one, and all this. Analysis, we are doing the data analytics, business are doing the business analysis. For what? Doing what? It's called sometimes, I will introduce later. It's a big question. Big question means philosophical question, psychological question. It's a sociology. What we are doing currently, all of this one, why we are here, like the Matrix program, right? Neo is thinking why I'm here, and it's a philosophical thinking and philosophical problem, right? So that is the reason sociology, they are interested in such a big data. They did the data analytics how? Survey user. What do you like? So for example, my question is, so problem is whether there is a relationship between gender and color. We believe the woman or the young lady or the girl likes the pink color, right? Rather than the boy. So how can I prove? The sociology department or the psychology department, they will survey, ask female, male, female, then collect and shows something, the error margin and standard deviation, then there might be relationship. What about the business guy? They have model, okay? Girl likes the pink. Then focus on the marketing when they advertise pink color, put the more pink color. Okay. What about the computer science? Nowadays, we are interested in whether we can help the sociology and the business guy to prove the relationship between color and the gender. So one of my students recently graduated, he did a research on that part. In his research, he collected all the images posted on, not all image, the all images from the one group in the Flickr. Okay? Then try to find a common factor or something related from the image, whether there is a clue for the gender. So if we can find such a clue or relationship from the image, we can just predict the image, the owner of this image, the 60%, the female or male, something like that. If we can do, this is a part of user profiling. User profiling means, so even though you do not release your personal information, think about when you read the Facebook posted message. Even though the user of the Facebook hide gender information or profile information, you can guess whether this user lives in Connecticut or not, where he lives, where she lives, whether she's or he is. Also age, the old guy, young guy, or elementary or children, you can guess, right? And also from the message, this guy is probably a very handsome guy, so I'd like to send a message to be a friend, right? So you can guess. We can apply the same idea to the computer science. So there are three ways to approach the big data. So business guy already did such a thing. However, this is a deterministic, which means we make the model. Okay, kind of a template. But it's a model. Model is ideal template, like the fashion model. Fashion model is ideal. The body of the human, the girl or man, then show up the new design of clothes. Like that, the business intelligence is deterministic. However, nowadays, so we are doing the predictive analytics using the big data. So it's moved from here business intelligence to the predictive analysis. It requires the more it deal with the complex data and complex the data mining technique and bigger data and the more data sources compared to others. So how to use the big data? It's actually in terms of the psychology and the sociology, it's a big question. Big question means philosophical or psychological question. Why I'm here? Eventually, okay? This is hard, almost impossible to answer such a big question in the traditional data. But in big data, maybe. I couldn't say we can do 100%, but in traditional, but comparing to the traditional data, using big data, we can answer. We may answer such a big question, psychological question, or the philosophical question. I'd like to give the three samples of the using big data. One is from harvest. It's a combiner. Combiner means it's a tractor that combines everything. Okay? Because we do not have a lot of farmers, so we need such a machine, right? That's true. Nowadays, it's from the European country. Then why don't we add bunch of the sensor in this to the combiner, like the GIS and the pressure, capacity, and the rotation sensor, and every sensor that has a temperature. Then each sensor will generate the data every second, every other second. Let's keep sending the data. We have the server to store such a data. Then how can we use such a data? A lot, actually. For example, we can make the optimize the track or trajectory to cultivate the farmland. Okay, because it has a GIS location, and also we have the information about whether this area is hard to cultivate or this area is good. So we can find optimize should is pass. Also, we can collect something information from the tractor itself, whether tire pressure is lower and whether the indicator that the item or part should be replaced. Then instead of waiting until new part is delivered, the company will send in advance that part. Then even the mechanic will go to there, then replace, then we can keep working for that one. So we can, and also we can predict whether this part is the fertilized or need fertilization, something like that. We can use a lot for this one. It's really the use for farming in European country. What about the Google? As I showed you before, the Google is one of the most possible source of the data to be matrix. I don't think that is good always, but focusing on our computer science perspective. But anyway, so how can we use the Google data? A lot. Still, the Google try to extend their research and their commercial knowledge. Right. So one of the simplest example of using such a Google data is the spelling check. How can you check the spelling? You need a dictionary and compare each and every one. You don't have to do that in the Google server. Why? Google has every time, every second, huge number of search keywords. So we can easily recognize which one is correct, which one is not. So in case I type I intended the bananas, but the S and A are, especially using the surface, is relatively small, so sometimes the mistyping. So yes, but Google knows it's frequently happens. It's kind of pattern. So suggest the banana instead of bananas or whatever. Okay, so it can be shown as this one. Even though I typed the BANANAS, this one shows that just in case search instead of bananas, I whatever this spelling, it shows the bananas like this one. Do you think Google check the spelling? I don't think so. Okay, they can do that, but they don't have to. For example, another way of using the Google when I write a paper, I'm not sure sometimes whether this is a plural or singular, or grammar. So long time ago, I should have checked my dictionary or the English book. I don't have to nowadays. I just type the Google search, then see how many you can. If for example, in terms of or in terms of. So in terms of is correct. Every time I got confused, right? If you type both of them, which one is higher return? In terms of, then that's true. That's a way of using. That's a way of how Google is using such a big data, because they have the more than 2 billion of search a day. Okay, so easily. Okay, which one is truth? Majority is truth. There is no truth actually, right? It's not fair, but it may be fair. I cannot say this one is true or this one is not. Anyway, that's the characteristic of the big data. There is no deterministic. Okay, as it is, we can get the truth. So that is the big data. This is another example of using big data in the LA, the police department, LAPD. They use the big data. They collected all crime information last of 80 years, then keep it. Then see what's going on. By region and time, then they can reduce the crime rate. They collect only the type of crime, place of crime, and time of crime. Type, place, and time. Only 3 information. They don't care the who did and who is the victim. No the personal information, no privacy information. But they use only type, place, and time for the 13 millions of the arrests lasted 80 years. Then they apply. They do not release the algorithm. But you can easily imagine what kind of algorithm they are using. They sum by, group by the region and time and the mapping, something like that. And also they open their data because there's no personal information, private information. So they release the data for those who wanna implement the algorithm. Then they can reduce the crime rate by the 12% of property, the crime and the burglary, by the 26%. How? They can patrol frequently for